Advanced Math Lesson 37. Part A is called Line as a Locus. Okay, so the word locus is a Latin word and it means place. And so we use that word when we're describing the location of points because they're at a particular place. Then the definition of a line, the locus version of that would be a line is the locus of all points in a plane that are equidistant from two specified points. And locus does mean place. You might just put the word group in there. It's the group of all points. Anyway, there's a drawing here trying to depict that. So the 2 points are A and B. And if we find a bunch of points that are equally distant to both of them, then they connect to form a line. And that's what they're showing you here with these dots. Each of these, D sub A, the distance from A to this point, is equal to the distance from B to that same point. And if that's the case for every single one of these, the distance there is the same as the distance there, and so on. And then you connect those, and that determines that line. Okay, so we're going to be using that to get equations of lines. First, we're going to just remember the distance formula, because we're talking about these distances being equal, and so we'll be using that formula. And so we're just going to restate it here. The distance between 2 points x1 minus x2 squared plus y1 minus y2 squared. Okay, that is our distance formula. And just remember, since you're squaring, it doesn't matter what order the x's and the y's are in, because when you square them you will get positives. And so you're adding whatever you get here to that and then square root it. That is the distance, and we'll be using that for these things. So and it says, remember, we can use the distance formula to find the distance between any 2 points. We'll be doing that. I don't think there's anything else we need to put up above there. Just going to go ahead and use it. So look at example 1. Find the equation of the line that is equidistant from those 2 points. And we're supposed to write the equation in slope-intercept form. Okay, which is the form we're used to working with. All right, so that means the distance from some point xy to 4, 2 is the same as the distance from that same point xy to -2, -3. So I'm just going to call that point A and point B, like up above. And so the distance from from A to xy will be over here. And that would be x minus 4, because the x coordinate, squared, plus y minus the y coordinate 2 squared. All right, that would be the distance from point xy, whatever it is, to A, to this point. And since they're supposed to be equally distant, we can say that distance is the same as x minus -2 is plus 2 squared, plus y minus -3 is plus 3 squared. And then we're going to rearrange this equation and get it into slope-intercept form. And the first thing we'll do is square both sides. Okay, first we were using the distance formula twice, really. There's for point A and there's for point B. And now we're going to square both sides. Square each side. And what that's going to do is remove the radicals. When you square square root, you get what's inside. Okay. And after that, we also are going to have to FOIL. So when I square each side, it's taking the radicals off, and I'm then going to write these out. If you're not in the habit of forgetting that middle term, you don't really need to write it out, but I want to make sure I don't forget here. So x minus 4 times x minus 4 plus y minus 2 times y minus 2 equals x plus 2 times x plus 2 plus y plus 3 times y plus 3. Okay, so we're squaring each side to get the radical off, but I'm also writing it out expanded to get ready to multiply. So for this one, we have x squared minus 8x plus 16. And then here we have y squared minus 4y plus 4. Just foiling. Over here we have x squared plus 4x plus 4, and then y squared plus 6y plus 9. And a lot of things are going to cancel. We can subtract x squared from both sides. They cancel. Subtract y squared from both sides. They're going to cancel. And now, if we're going for slope-intercept form, y equals mx plus b, I need the y's all on one side and everything else on the other side. So at this point, I'm going to start doing that. Move the x to the right side. It'll cancel over here. I need the constant on the other side as well. So minus 16, but also minus 4. So I'm subtracting 20 from both sides. Okay, so that. Okay, all I have left on this side is negative 4y, so we're getting there. Negative 4y equals, okay, cancel, cancel. I'm going to have to move that y also. I shouldn't have written this yet. We can do that in one step. Okay, so this y has to come over. It was a positive. I subtract 6y from both sides. This is negative 10y. Okay, and now we have, those are both positive, 12x, and then we have 13 minus 20, that would be minus 7. Make sure I didn't miss anything. Okay, all I'm doing is adding like terms now on each side. And we need positive 1y equals the other stuff. So we're dividing by the coefficient. Y equals, and then that reduces. This will be negative 6/5 x plus 7/10. Okay, and that is it. It's in slope-intercept form. We are done with that one. Okay, have another one to try back here. Find the equation of the line that is equidistant from these 2 points. So, same process. Here's my A and B. So the distance from x, y to 0, negative 4, I'll do on this side. Okay, so it's x minus 0. I wouldn't need to write the minus 0, but I'll just put it directly into the formula. And y minus negative 4, so plus 4 squared. Okay, 0 minus negative 4. Now for the B side, we have x minus 5 squared plus y minus 2 squared. I think I forgot to keep writing notes on the side before. Let's do this again. So we have distance formula. And then we're going to square each side to remove the radicals. And while I'm doing that, I'll also get ready to square all these other things that were inside. This is just x squared. I'm going to go ahead and write it like that now. And then this one is y plus 4 times y plus 4. And then here we have x minus 5 times x minus 5 plus y minus 2 times y minus 2. And then we FOIL. Y squared plus 8y plus 16, x squared minus 10x plus 25, y squared minus 4y plus 4. Okay, and then we're going to rearrange things. We're doing slope-intercept form again. So I'm just going to put rearrange equation. And again, we want y on the left, everything else on the right. So this and minus y squared, keeping the y here, subtract 16. I chose to put it into the 25, so, it's normal subtraction. Now, all we have left here is a y, but over here there's that y. It needs to go left. It was minus 4y, so I'll add 4y. Okay. Now, canceled, canceled, canceled. 12y equals canceled, canceled, canceled. X is just there, negative 10x. Then we have, for the constants, 25 minus 16 is 9, plus 4 is 13. We divide everything by 12. There's just enough room here, almost. Okay, so y equals, I added like terms there. Now I'm dividing everything by the coefficient of y, and this is going to reduce. It's negative. They're both even, so we have 5/6 x. This one doesn't reduce, so that is our equation. And that's it. Okay, the midpoint formula. There it is. We're given 2 points. Here are the coordinates of the 2 points. Here's how you find the midpoint. Add the x's, divide by 2. Add the y's, divide by 2. That will give you the midpoint, the point that is halfway between those 2 points. Simple as that. Okay, so I don't think there's much else we need to write except just to do that example. There is some explanation in the book if you want to take a look in lesson 37. But I think we're just going to go ahead to example 3. There we go. Okay, so there are the 2 coordinates. We're going to use the formula. Okay, so the midpoint is, add the x's, so negative 2 plus 4, and divide by 2. Add the y's, so 6 plus negative 10, 6 minus 10, divide by 2. Simplify them, and that'll be it. Okay, add the x's, divide by 2. Add the y's, divide by 2. 4 minus 2 is 2. This is negative 4 on the top. So we have 1, negative 2. That's it. You can graph them and prove it to yourself if you want, but that's all you need to do. Basically, find the mean of the x's and the mean of the y's, and that's it. Have fun!